Good morning and welcome to another edition of COVID Math. Today we're going to take a look at the practice questions from section 7.2 in your math module, which has to do with writing linear equations in general form. Now remember, this whole chapter is basically looking at different ways that you can write the equation for a linear relation and rearranging to go from one form to another. So in 7.1 we looked at the slope-intercept form for a linear equation, y equals mx plus b, where again the value for m gives you the slope of your equation, the value for b gives you your y-intercept, and knowing those two things, you can then plot points, use the slope, and join the points to graph your line. 7.2 looks at a different way of arranging an equation, which is called the general form, and the general form is right here. Ax plus by plus c equals 0. And remember, we said that a, b, and c are a, b, and c are coefficients or numbers. A has to be positive, and no fractions or decimals allowed. Okay, now remember, I have already posted a YouTube video that gave more of a lesson for general form of the linear equation. Today's class, I'm just going to go over some examples. Okay, so these are the practice questions from your module. We'll go through them, and that'll be today's lesson. Okay, so the first skill you need to be very good at for this chapter is to have an ability to rearrange equations from one form to another. So what you've been given here are equations that are in the slope-intercept form, y equals mx plus b, and you've been asked to rearrange them into the general form, ax plus by plus c equals 0. So we're going to do that. So remember, the first step in rearranging these equations is to move everything to one side. Okay? And generally, when they're in slope-intercept form, it's easier to just move your y variable over, because all you need to do that is just subtract y from both sides. When we subtract y from this side, y minus y gives us 0. And then when we subtract y from this side, because there are no like terms to combine it with, our equation just becomes minus 3x minus y minus 6. Okay? After you've moved everything to one side, you have to check the two things. You can't have a negative a, so no negative a. And you can see we do have a negative coefficient of x. That's our a value, right? The number attached to x. So we're going to have to deal with that. And remember, we also said no fractions or decimals. Now, luckily, we don't have any fractions or decimals, so nothing to deal with there. Okay, but we do have to deal with that negative in front of the 3. And that's very easily dealt with. We simply take our entire equation, even the left side, and we multiply it through by negative 1. Okay, so remember from a previous chapter polynomials where we talked about using the distributive law, you simply multiply your -1 by every term inside the brackets. There are 4 terms here, so you're going to multiply by all 4. -1 times 0 is 0. -1 times -3 will give us +3. Notice that's given us a positive coefficient of x. -1 times -y, negative times negative will give us plus or positive y, and -1 times -6 will give us +6. And we are done. Pat ourselves on the back and move on. Our next question has a fraction in it, so we're going to have to deal with getting rid of that fraction eventually. But remember, we always want to go through the same series of steps. Okay, that's a nice thing about math. It's very kind of regimented. Once you learn the rules, you apply them every time. Okay, so again, we're going to move the y across to the other side. So we're going to subtract y from both sides. Y minus y gives us 0. And on this side, we'll have 2/3 x minus y minus 7. Okay? Now, we don't have to worry about the -a this time. Our a value, the number attached to x, is positive already, so no worries there. However, we do have a fraction. And remember, to get rid of that fraction, we simply multiply everything through. And this time we're going to multiply everything through by the denominator. Okay? Now, if we have more than one fraction in our equation, it has to be the least common denominator. But in this case, we only have that denominator of 3. So that means we're going to have to multiply everything through by 3. And again, remember, we're going to distribute it over everything. So we're going to go 3 times 0, that gives us 0. 3 times 2, that gives us 6 over 3x. 3 times -1, remember there's a coefficient of 1 in front of the y, that will give us -3y. And 3 times -7, -21. Okay? The reason for doing this is to give us a numerator that we can simplify with our denominator to give us a whole number. 6 over 3 simplifies to 2, and that gets rid of our fraction. So 2x minus 3y minus 21. And again, we are done. Moving right along. Now, remember in a previous lesson, I told you we had special cases, okay? And those special cases were horizontal lines and vertical lines. The equation of a horizontal line will always be y equals n, where n is simply a number. The equation for a vertical line, that is a line that's straight up and down, will be x equals n, where again, n is any number. Okay? Now, in these particular cases, n, whoops, you're not going to be able to see that, are you? In the case of a horizontal line, n is the y-intercept. So the point where our horizontal line crosses the y-axis, and I'll just give us some axes, y-axis, x-axis. Okay? So in a horizontal line, this value of n is the y-intercept. In a vertical line, this value of n is the x-intercept. So, if we take a look at our equation here, we see it's one of this type, okay? So as soon as you see that your only variable is x, notice that there's no y here, what you should be saying to yourself is, oh, all I have is an x, that means I have a vertical line, and that means I have a vertical line with an x-intercept of -5. Okay? So, as soon as I know that, the rest is easy. Okay? I have an x-intercept at -5. Well, where is that? 1, 2, 3, 4, 5. My x-intercept is right here at -5 and 0. Remember, for the intercepts, one of the coordinates will always be 0. Okay? For the x-intercept, it's the y-coordinate that will always be 0. Now that I know where it crosses the line, and I know because it's only got one variable, and that variable is x, I know that it's a vertical line. So, easy. There we go. Sketch the line. Okay? If I had a different equation, let's say my equation was y equals 4 rather than x equals -5, then I would have a horizontal line, right? Where I only have one variable and that variable is y. Remember, whatever the variable is, that's telling you which intercept you're after. Since my variable is y and my number is 4, that means I now have a horizontal line with a y-intercept, right? Because you can see there's a y there, of 4. So, 1, 2, 3, 4, there I am. The coordinates of that point are at 0 for the x, 4 for the y, and this time it's a horizontal line. Okay? So just remember, if there's only one variable, it's going to be one of those special cases. So it says, let's just get rid of some of this. It says the y-axis can be represented by the equation x equals 0. So again, remember, we have an equation with only one variable. That variable is x, so that's giving us a vertical line and telling us the x-intercept. Okay? What is the x-intercept? Well, as I told you, that number over there is the x-intercept. So the x-intercept is at 0. The line x equals 0 has an infinite number of y-intercepts. Explain what this means. Well, easier to show. So here's our y, here's our x, and we've said that our equation is x equals 0. So that means, again, since we have x as our variable, we're dealing with a vertical line. Our vertical line crosses the x-axis at 0. So that means, and I'm just going to draw it squiggly because I need to differentiate it, but if it's crossing the x-axis at 0, that means we have a line that's going to be perfectly vertical and is going to run right down the y-axis. Okay? So, what's the y-intercept of this blue line? Well, if you think about it, it's all over the y-axis. It crosses the y-axis at every point on that axis, and that's why we can say for this line, x equals 0, there are an infinite number of y-intercepts, because every single point on the y-axis will be crossed by this line. Okay, so So explain what this means. Every point on the y-axis is crossed by the line x equals 0. Okay? State the equation of a vertical line that passes through the point 5 and negative 7. Okay, so if it's a vertical line, we know it's going to have this kind of an equation. X equals n. And we also know that the value of n, so we'll say value of n is, in this case, the x intercept. Well, if it passes through this point at 5 and negative 7, where is it going to cross the x-intercept? Again, better to show you than to tell you. So, our y-axis, our x-axis, and it says it passes through the point 5 and negative 7. Well, where is that? That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Here we are at 5 and negative 7. Well, we've already established, since it has x as its variable, it's a vertical line. It passes through this point. So by drawing it, it has to be vertical, it has to pass through this point. That means it's got to look like this. In other words, where does it cross the x-axis? Right there at 5. So the coordinates of the x-intercept will have the same x value as every other point on this line. All points on this line will have an x-coordinate of 5, right? If we have a point here, that will be at 5 and negative 5. If we have a point up here, that will be at 5 and 2. Notice every single point has an x-coordinate of 5, okay? Moving right along to Pravin. And here's where we get into word problems, which sometimes have their own unique challenges. Okay, so Pravin is planting a garden of tomatoes and pumpkins. His garden has a total area of 300 feet squared. Pravin writes the following equation to represent the number of plants he can include. As you might imagine, the variable t is for tomatoes, the variable p is for pumpkins, the number 300 is the area of his garden. So, explain what you expect each term of Pravin's equation to represent. Well, we've got some amount of tomatoes and some amount of pumpkins, and all together they add up to 300 square feet. So, if we're talking about an area here, and we're adding these things together, they have to be like terms. So this is going to be an area as well as this. Okay? T will be the number of tomato plants, P will be the number of pumpkin plants, and the numbers 4 and 25 will be areas. So, explain what you expect each term to represent. For T will be the area of tomato plants. In other words, we have a certain number of tomato plants. Each one needs 4 square feet of space to grow. We have a certain number of pumpkin plants, and each pumpkin plant requires a lot more. If you've ever seen a pumpkin plant, you know they spread out. So, 25P will be the area of all the pumpkin plants. And our 300 is the total available area. So the total area of the garden. Okay, so if we take the total area of tomato plants, if we add to that the total area of pumpkin plants, that will give us the total area of the garden. If Pravin plans to plant 30 tomato plants, how many pumpkin plants can he use? So in other words, what are they saying to us? Whoops, too far. They're saying in this particular case, T equals 30. We have 30 tomato plants, okay? So we take our equation, 4T plus 25P equals 300, and if they're asking us how many pumpkin plants, they're saying solve for P, find the value for P, okay? Knowing that T equals 30. Okay, just let me make some room here. So if T equals 30, we substitute that value for T. So it becomes 4 times 30 plants plus 25P equals 300. Simplify the left side. 4 times 30 is 20 plus 25P equals 300. Now we have to isolate the variable. Notice we're rearranging equations again. This is a absolutely integral skill for this chapter. You have to be able to do this. Okay? So we got to get rid of the 120, we got to get rid of the 25. Since 25 is multiplied by P, we don't get rid of it. First, we get rid of the 120, which requires subtraction. So we're going to subtract 120 from both sides. 120 minus 120 leaves us with 25P. On this side, 300 minus 120 will give us 180. Okay? To get rid of the 25, since it's multiplied, we need to divide both sides by 25. 25 divided by 25 leaves us with 1P, and 180 divided by 25 gives us something. What it gives us is 7.2. Now, this is where you ask yourself a common sense question. Since this number refers to a number of plants, you can't have 7.2 pumpkin plants. Okay? So, decide based on the question whether you should round up or down. In this case, it makes sense to round up. Sorry, I said up, I meant down. It makes sense to round down. You have 7 pumpkin plants. Okay? 8 pumpkin plants would not fit, but 7 would. You'd have a little bit of space left over. Okay? Whoop. So it says, Ryan says that he can graph a linear relation in general form without using x and y intercepts. Below is his work showing how to graph 4x minus 6y minus 48 using this strategy. So I'm just going to quickly explain what our buddy Ryan did here. What Ryan did was basically what you do whenever you create a table of values in order to find points to plot. Okay, we'll just move this over here a little bit. Okay, so you've got x values and y values, and you have this equation. So all Ryan did was he just said, well, I'm going to pick an x value of 3. And that's totally fine. It will work in every case except those special cases of horizontal and vertical lines. But this has both an x and a y variable, so we know it's not one of those special cases. So all Ryan did was he chose a value for x of 3, he subbed it in, he simplified the left side, and then he rearranged the equation, right? He added 36 to both sides. That's why the 36 disappears from here, reappears over here. And then he divided through by -6, and that's how he came up with a y value of -6. That gives him 1 point, right? The point that gives him is 3 and -6. So he's got 1 point he can plot. What Ryan did over here was he simply chose another x value. This time he chose x equals 9. He did exactly the same thing, subbed in a value of 9, simplified his equation, isolated his variable, right, added 12 to both sides, and then divided through by -6 to give him a y value of -2. There's another point at 9 and -2. And as I've said to you many times, once you have 2 points, you simply plot those 2 points and join them up. And that's what Ryan did here. He plotted his first point at 3 and -6, his second point at 9 and -2, joined them together, and he got his line. Ryan is such a smart guy, so I just explained the strategy. Why might you prefer to use the intercepts? It just makes life easier, because if you use a value of 0, then this whole term disappears and it just gives you fewer numbers to work with. There's absolutely no reason why you would have to use the intercepts. It just makes it a little bit easier. Okay? Okay, we're getting near to the end. Hopefully we can get the last couple of questions done. So, Galaxy High School students want to raise $1,200 to support their student government activities. They sell sweatshirts with a profit of $5.75 and t-shirts with a profit of $3.50. Let's pick some variables here. We'll say, we'll put it here. Let S equal the number of sweatshirts, and let T equal the number of t-shirts. Okay? So this is very important for the next chapter. Whenever you're coming up with an equation, you need to actually write down what your variables will be. Okay? So, write a linear equation that represents the number of each type of shirt needing to be sold to reach their goal. And their goal is right there, $1,200. So, we have a certain number of sweatshirts, and for every sweatshirt we sell, we make this much money. So, the amount of money we can make by selling sweatshirts is this term here. $5.75 times the number of sweatshirts. But we're also selling t-shirts. And our t-shirts give us a profit of $3.50. So a term to describe the profit we could make by selling t-shirts is 3.50 times the number of t-shirts. Add the profit from selling sweatshirts to the profit from selling t-shirts, and all together, we get our $1,200. Okay, so there's our linear equation. State the domain and range of the graph of the relation if the students plan to stop selling once they've raised $1,200. So, what we need to do here is figure out what's the minimum and maximum number of t-shirts we could sell, what's the minimum and maximum number of sweatshirts we could sell. So what they're really asking for here is the intercepts. So let's just say that S will be our domain variable and T will be our range variable. Okay? So, in order to find, let's deal with the sweatshirts first. We know that the minimum number of sweatshirts we could sell is 0. Okay? Maybe we sell no sweatshirts, all t-shirts, and we still make our $1,200. Okay? So, that would equate to, and where's our equation? Let's just put this over here for our domain. Our range will use the same logic. By the way, this is interval notation. Remember that from last chapter? Okay. Excuse me. Okay, so if we sold all sweatshirts, no t-shirts, our equation would look like this. 5.75 S, so we're going to sell all sweatshirts. If we sold no t-shirts, hold on a second because I don't remember, 350. If we sold no t-shirts, then we would know what our value of t is. Our value of t in that case would be 0, okay? Because we haven't sold any sweatshirts. Any t-shirts, we've only sold sweatshirts. Altogether, that has to equal $1,200, okay? So now we have an equation. We have a value for one of our variables. We just have to figure out what our other variable is. Well, 350 times 0 is 0, so that term completely disappears, and we have 5.75s equals 1,200, and then to isolate s, we divide both sides through by 5.75, and we get a value for s of 208.7. Now again, think back and decide, should we round this up to 209 or down to 208? Well, if we only sold 208 sweatshirts, we wouldn't quite make $1,200. Okay? We'd make a little bit less. So in this case, if we want to get to $1,200, we would have to sell 209 sweatshirts. Okay? Almost, but not quite. So, if we sell 0 t-shirts, we sell 209 sweatshirts. Okay? Now what about the other way around? What about if we sell no sweatshirts and all t-shirts? Well, then our equation becomes no sweatshirts and all t-shirts, and then this first term disappears and we're left with 3.50t equals 1,200, divide through by 3.50. 3.50 divided by 3.50 leaves us with t. And we get 342.9. So 342.9, that means, again, within the context of the question, we would have to sell 343 t-shirts in order to make our $1,200. So our range then, the number of t-shirts, anywhere from selling 0 to selling a maximum of 343. Okay, so there's our domain. Sweatshirts would go from a minimum of 0 to a maximum of 209. T-shirts would go from a minimum of 0 to a maximum of 343. Okay. Look at that. We're done. We'll have more fun lessons later. See ya.